Conduction. If you stir a boiling liquid with a plastic ladle, after a few moments, the ladle will become quite warm. The same will happen with a wooden ladle. And a ladle made of metal can even become too hot to handle. This is because the heat from the boiling liquid is able to travel up the length of the three ladles, quite slowly through plastic and wood, and very fast through metal. But how does heat manage to do this? How does heat travel through things? Well, when the hot liquid heats up the end of each ladle, its molecules, or in the case of metal, its individual atoms, start to vibrate more rapidly. And when the heated molecules, or heated atoms, vibrate faster, they start bumping faster and faster into their slower neighbors, causing them to speed up in turn, and bump into their neighbors, and so on all along the ladle. In this way, the increased speed of vibration, and therefore the heat, is passed on from molecule to molecule, or from atom to atom. Heat is conducted by a sort of domino effect from molecule to molecule, or from atom to atom, along the hot object and into your fingers. That's one kind of heat transfer. Convection. The hot object causes the molecules of air above it to speed up. The hot air expands and becomes less dense, and is therefore conveyed upwards. That's a second kind of heat transfer. You look nice and warm. Where does the heat for that hot water radiator come from? The furnace, of course. Is the furnace always kept in the basement? Why couldn't it be in the attic for a change? What would happen if it were? Anyone on a floor below would freeze. That's what would happen. Why is this? The furnace heats the water in a tank. The hot water rises up through these pipes and into the radiators, where it cools, and then the cold water flows down through these pipes and back into the tank, where it is heated up again, and so on. But why does hot water go up and cold water go down? Because of the principle of buoyancy. If you hold something that is less dense than water, such as a cork, in the middle of a beaker of water, the buoyant force pushing that cork up will be greater than the force of gravity pulling it down. And as soon as you take your hand away, the cork will rise to the surface. Now, when water is heated, its molecules speed up and it expands and becomes less dense. And this less dense water will therefore go up, and then cool and become dense again, and therefore go down. And that's exactly how hot water heating systems work, and why your furnace is in the basement. The principle of buoyancy applies as much to gases as it does to liquids. When air is heated, its molecules speed up, and it expands, and becomes less dense. And so hot air rises, just as hot water rises. Hot air goes up, it cools, and the cold air goes down. Since the behavior of gases and liquids is so similar in this and many other respects, but how can the sun transfer heat to you? You're not touching it, so there can't be any conduction, can there? And since most of the space between you and the sun is just that, space, except for the thin layer of air formed by the Earth's atmosphere, there can't be any convection either, can there? Because once you get beyond our atmosphere, there's almost nothing out there to do the convecting. But the sun still feels hot. Amazing. How is that possible? Is there a third kind of heat transfer which allows heat to move through empty space? Yes, there is. And to understand it, you must first of all remember that heat is a form of energy. Now, energy can travel in various ways, but one of the chief ways in which heat energy travels is in the form of waves. By means of waves, energy can move through any distance. You can do it yourself. You can make that umbrella move without touching it. Tie one end of your rope to the umbrella, and now move your end of the rope up and down.
you can actually see that your energy is traveling through the space between you and the umbrella, and then making the umbrella move. The heat energy from the sun travels like that. The sun sends out waves of heat energy in all directions. Each of them is rather like the spoke of a wheel, and this is exactly what scientists call them, only they use the Latin word for spoke, which is radius, from which they get the word radiation, the name given to this third kind of heat transfer.
So it's by means of radiation waves that the sun can transfer its heat energy to you and make your molecules go faster and therefore make you hotter, even though the sun is millions of miles away. Just as by means of waves again, you can transfer your energy to the umbrella and make it move, even though you're standing several meters away from it.